Hi friends, in this video I have taken a new topic in the same concept of interpolation, that is Lagrange's interpolation formula. Lagrange's interpolation formula. So you know very well Lagrange's interpolation formula will be applicable for equal interval and unequal intervals also. Right. Let us see about it. Let the function y equal to f of x and x values are arguments, you know very well, and y values are entries. Here may the values of x may or may not be equal. If it is equal also, I can solve with the help of Lagrange's interpolation formula. If it is not equally spaced, x values are not equally spaced, equal or unequal, for both of the cases I can use Lagrange's interpolation formula. That's what the thing I have given here. It is applicable for both equal and unequal intervals. One important clue is here. If you want to find the value, I'm giving x, find y at x equal to some k. If you want to find y, that is, we're going to use Lagrange's interpolation formula. Suppose in my question I'm asking, find x at y equal to some k1. Then what I have to do? Finding y here, finding x. This is the only advantage we are having in the this is the additional advantage, not only the only advantage. This is the additional advantage we are having in the Lagrange's interpolation formula. If you want to find the value of x for the respective y value, we can find it. Similarly, we can do that in the reverse. If you know that value of y, we can find x also. That is the inverse Lagrange's interpolation formula we are going to use. So if you want to find the value of y, we are going to use interpolation formula, Lagrange's interpolation. If we are going to find the value of x, we are going to use Lagrange's inverse interpolation formula here. So two formulae are here in this topic we are going to discuss now. Now come to the topic. Yeah, Lagrange's interpolation formula. This is what the Lagrange's interpolation formula plus etc. So what will be here? X values are the known one, y values also the known one, x0, x1, x2, etc., x suffix n, y0, y1, y2, etc., y suffix n. For this data, so we have to find the value of y. So we are going to use Lagrange's interpolation formula. So here I am going to give one important clue, guys. Just listen very carefully. Uh, this clue will help you to understand the formula because it will be the way it's look like very lengthiest one. But if you understand the clue, what I'm going to give now, it will be easy to understand. Right? It will be easy to write the formula. So look at the first term. I'm going to subtract with the other values, argument values with the x, whatever I'm going to find. So x minus x1, the first term, x0 is going to miss. In the second term, x1 won't be there. In the third term, x2 won't be there. In the fourth term, the next term, it is x3 won't be there. Then what? In which way you have to remember that? Just listen. I missed the value of x0. I am not going to subtract by x0 in the first one. So x minus x1, x minus x2, x minus 3, x3. So which value we have omitted here? x0. Subtract by that value. Replace x by here x0. The right hand side value will be similar. Here x0. Here x0. That's it. So numerator x0 is missing. Denominator replace x by x0. Right hand side value will be similar. Now tell me this. The second term now. In this form, second term, x1 is missing. X minus x0, x minus x2, x minus x3. x1 is missing. So I am going to replace x by x1 here. Other values are same. Into y1 will be there. Similarly, for the next term, numerator, look at the numerator. X minus x0, x minus x1, into x minus x3. x2 is missing. So first term, first value is missing, x naught. Second term, second value is missing. Third term, third value is missing in the numerator. Fourth term, fourth value is missing in the numerator. So in the denominator, you have to replace by x2 is missing now. So replace by x2, x by x2. Look at that. In the place of x, it will be x2. Other values are same. Similarly, the next value, next term, x3 is missing. So replace x by x3. I hope you have understand. So numerator, x naught is missing here. So replace x by x naught in the denominator. Other sign and everything, the rest of the values are similar. Multiply by y naught. Plus x1 is missing in the numerator. Replace x by x1 in the denominator. Everything apart from everything will be similar into y1. Likewise, you have to write the rest of the term. So this is what the concept we are having in the Lagrange's interpolation formula. Right. Suppose we have to find the here we found y value. We have to find the x value. So what I have to do now? So I have to find the x. So my x values are given for the given table values x naught, x1, x2, etc. xn, y naught, y1, y2, etc. yn. Now I have to find the x value for the some value of y. Some value of y k is k1 here. I have to find the respective x value. What is x? So in Lagrange's only we have such kind of advantage. In other formulae we don't have any inverse concept. Only in the previous topics only we found the value of y for the given value of x. Here only we have an advantage. We can find x value for the corresponding y. So what I have to do here? So it's a similar one. What we have done earlier, in the place of x, y is here. In the place of y, x is here. That's it. Look at that in this place also. Previous formula is x minus x1, x minus x2, x minus x3 divided by, which is missing, x naught is missing. We will replace by x naught. X naught minus x1 into x naught minus x2, x naught minus x3 into y naught. This is the first term we have written in the previous formula, Lagrange's formula for y. So it is entirely opposite. In the place of x, replace y, replace x by y. Look at that. Here it is x, but here it is y. Here the values are in x. Here everything is in y. Here y naught. Here x naught. That's it. If you know the Lagrange's interpolation formula, it will be easy to write Lagrange's inverse interpolation formula. So simple thing, while you're starting with the Lagrange's formula, try to y first. If you're starting with y first, then x and then y. If you're starting with the inverse interpolation formula, first x we have to find, and then y, and then the multiplication x. That's what that. This is the clue. If you follow that clue, it will be easy to write the formula and easy to understand the concept also. That's it. Similarly, in the next term, which will be which won't be there in the numerator, y1 won't be there numerator. In the denominator, we are going to replace y by y1. Similarly, in the third term, y2 won't be there. We are going to replace y by y2 here. Apart from that, all the terms are there into x2 plus next term also. So these are the two formulae we are having in this topic: Lagrange's interpolation formula and Lagrange's inverse interpolation formula. In this video, I have given few problems in the particular topic of Lagrange's interpolation formula, that is finding the value of y only. I have given the separate video for inverse interpolation formula. Uh, if you want to watch it, please go and check Lagrange's inverse interpolation formula and watch it. Yeah, come to the topic now. This is the first example in the Lagrange's interpolation formula. Look at that. 5, 6, 9, 11. So what about the values? The values are unequally spaced. As I told you already, Lagrange's interpolation formula will be applicable for equal and unequal intervals also. For both, it is applicable. Clear? Right. So here 5, 6, 9, 11. Here also it is in ascending order. 12, 13, 14, 16. Both are in ascending order. So we can check whether the answer is right or wrong. We are going to find y of 10. The value will be here. Then conformally, y value will be between 14 and 16. So if you are getting the answer before 14 or after 16, it is absolutely wrong. This is the way you have to conclude your answer, whether it is right or wrong. Right, come to the problem now. Solution. So what is the value we have to find? Y of 10. Here y of 10 represents, find the value of y at x equal to 10. That is what the meaning. Y of x. This is the way we always will define the function y of x. X equal to 10. What is the value of y? So y only we have to find. If you want to find y, it is normal Lagrange's formula only. If you want to find the x value, that is what we didn't do in the previous topics. In the previous topics, we had done with everything with we found y alone. So in this topic only, we can find x also. So if you want to find x, it is inverse interpolation. Normal y value, as usual, what we find, that is only in Lagrange's interpolation formula. So Lagrange's interpolation formula we are going to take. So we have to write, we have to find y value, y equivalent to some x, in terms of x will be there into n. First term, second term. First term you know very well, x naught won't be there. The second term, x1 won't be there in the numerator. Denominator will change by the same. Replace x by that same. Third term, x2 won't be there. Fourth term, x3 won't be there. Right. We have written the formula where we have to take the values. What are the values of x1, x2, x3, and y0, y1, y2, y3? Where we have to take the values? It's so simple. Here we no need to do any difference table. What we had done earlier, forward difference table or divided difference table, nothing. We no need to find anything here. So from the given data, we can write what is here. 5 is, this is first value of x is x naught. This is my x1. This is my x2. This is my x3. And first value of y is y naught, y1, y2, y3. That's it, guys. So we have to take the values from the given data, not we are going to form any table or any some other thing additionally here. Directly write the formula, choose the values from the given table. That's it. So what is your x? Here, x is not, whatever we are finding, that will be our x. You know very well. That's it. So replace by that value now. Y of x is equivalent to x minus 6. What is x1? x1 value is 6. This is x naught, x1, x2, x3. So x1 value is 6. And x2 value is 9. X3 value is 11. Which is missing? X naught. 5 values missing. So replace 5 by x by 5. Right hand side value will be same. X by 5. Right hand side value will be same. X by 5. Right hand side will be same. Into y naught. Y naught value will be the first one. Similarly, substitute for rest of the terms. Second term, third term, and fourth term. Now we have to find y of 10. Now replace x by 10. Guys, it will be easiest topic, easily get marks. It's a very simplest one. Formula it is look like longer, but it'll be easy to get marks here. Right, because we are not going to do manually. We no need to multiply all the times, divide the times manually. It won't get more time to do that because we can use the calculator. Right. Now in the place of x, replace by 10. That's what I am doing here. Yeah, look at that. I replaced the x by 10 in all the places. That's it. Then how can you find the values now? Uh, I already have given the clue, even though I will repeat it again. So for the first term, I am going to explain. Likewise, try to do the rest of the terms also. Take your calculator, open a brace, 10 minus 6, and then 10 minus 9. Open a brace, give it in that brace. If you are giving like that, it is understood, it is in multiplication. You no need to give int symbol here. Right. So again, 10 minus 11. Good. Into again this value, whatever the values are there in the multiplication, you can give that. That's it. I have given the numerator 4 values. This, and this. If you're having minus 12 like that, you can give in the inside the base minus 12. That's why if you're doing like that, it will be so easy. You can save your time in your exam, and you won't do any mistakes also. And then what I had to do, divided by the denominator terms. 5 minus 6 into 5 minus 9 into 5 minus 11. That's it, guys. If you're giving like that, easily you can get the answer for the first term. Similarly, try to do the same procedure for the second term, third term, as well as fourth term. If you're doing like that with your calculator, you can get the answer. First value 2, and then second value, third value, fourth value. Then the answer is 14.667. So what it is? Y of 10 is equivalent to 14.667. How to conclude it? Whether the answer is right or wrong, and when we can conclude? Yeah, exactly. Our value should be, it should be in the ascending order. Look at that. X values of 5, 6, 9, 11, 12, 13, 14, 16. So y of 10 we are finding here. Y of 10. This place. So what is the value of y? 14.666. Someone we found it. We'll check it. 14.667. Yeah. So look at that. It is lying between 14 and 16. That's it. This is the way to do the cross check, guys. To do the cross check, I will repeat it again. It should be in the ascending order, or it should be in the ascending order, or it may be in the descending order also. That should be the main thing to do that. Right. Similarly, so this is what the answer. Similarly, I have given one more problem to do that. Look at the problem. With the help of, particularly I had chosen this problem. Easily you can identify why I have chosen problem, I think so. Right. Using Lagrange's interpolation, find Y of 9.5, obviously. When you are asking for inverse interpolation also, they will use Lagrange's interpolation only. They won't particularly mention Lagrange's inverse interpolation. You should conclude with the help of this only. If you want to find Y, it is in normal interpolation, Lagrange's interpolation. If you want to find the value of X, it will be Lagrange's inverse interpolation formula. That is the thing you should conclude with the help of the given question itself. Right. What is the advantage in this question? Look at that interval 7, 8, 9, 10. Suppose without giving that, I asked this question without mentioning the Lagrange's interpolation formula. Find Y of 9.5 from the following data. What are the thing I can do? I can use Newton's forward interpolation, Newton's backward interpolation, like that. So Y of 9.5 is after the middle level. I can use that. But particularly they have mentioned, we know very well Lagrange's interpolation is applicable for equal and unequal. Got it? Right. So that's why particularly I have chosen this problem. 7, 8, 9, 10. It is equally spaced. Right. So we have to find Y value only at x equal to 9.5. We can use Lagrange's interpolation formula. Write the formula. First value x0 won't be there. Second term x1 won't be there. Third term third value won't be there. Fourth term fourth value won't be there. Denominator, that value will be there. You have to subtract by that value by the rest of the values. Right. Now substitute the values. This will be x0, x0, x1, x2, x3, y0, y1, y2, y3. So as I told you already in the previous problem also, you no need to find any other additional tables here. So directly we are going to substitute in the formula. Substituted, we are having 4 times. And now replace x by 9.5. Replace x by 9.5. Yeah, this will be exactly. So the final answer will be y of 9.5 is 3.625. Earlier solving the terms, I use the clue what I have given for the previous problem. Try to give the numerator values everything with the brace, and then finally divided by the denominator value. Divided by, you have to give the denominator value in with the brace. It will be easy to calculate, and we won't commit any mistakes also. That's it. Y of 9.5 equivalent to 3.625. Here it is the given values of y, it is not in ascending order, so we can't be able to come to the conclusion whether it is right or wrong. Right. I have given a note problem. Use Lagrange's interpolation formula to fit a polynomial. To fit a polynomial. Look at that, right? We have to fit the polynomial now. Polynomial means we have to fit the equation, and then only we have to find the values. Got it? So we have to fit the polynomial first, and then we have to find the value of x equal to 1. Look at that. Here the values are -1, 0, 1, 2, 3. -1, after -1, 0. After 0, 1 should be there. So it is unequally spaced. We have to find the value of y only. So we can use Lagrange's interpolation formula. So I have written Lagrange's interpolation formula. Right. Thereafter, I have given the same clue in the previous topic also when we are doing the divided difference concept. If you want to fit the polynomial, do not fit the polynomial first and then don't find the value. Try to find the value first. First to find y of 1. So what you have to do for that? Replace x by 1 here. 1 minus 0, 1 minus 2, 1 minus 3 divided by -1 minus 0, -1 minus 2, -1 minus 3 into -8. Plus similarly, I substitute that value, simplify this, then you can get the final answer. Some take that as k1. So you can get the answer. Try to find the equation finally, because so for which purpose I asked to do in that way. If you fit the polynomial first, suppose if you are doing the mistake like x cube somewhat x square plus x plus 1, it will get like that. If you're doing any mistake plus or minus sign here, what you will get finally? It will be, if the equation is wrong, then finally I have to substitute x by 1. I have to replace x by 1. That value also will be wrong. So you can't be able to get full marks. So that's why, suppose if you want to, if they're asking to find the polynomial and then finding the value of y at x equal to some other values, whatever they're going to give there, fit the polynomial, do not fit the polynomial first, try to find the value first, and thereafter try to fit the polynomial. There you can do the cross check whether the answer, we are getting the same answer or not. That is what you have to do, right? So multiply everything to get the polynomial. So we will get 2x cube minus 6x square plus 3x plus 3. Then if you are replacing it by 1, you can get this answer. That's it. Y of 1 equivalent to 2. That's it, guys. So these are the problems there in this video lecture. In the next video, I will give you some different problems under the inverse interpolation concept, Lagrange's inverse interpolation concept. Okay, thank you for watching. If you like this video, subscribe it and share to your friends. Thank you, guys. Thank you very much.